So the curve C has this equation y equals to kx cubed. We know that kx cubed we're going to look like that lah. Okay, this graph here. Now the thing is, the tangent at point P at C on C meets a curve at Q. Tangent at Q meets a curve again at R. If the x coordinate PQR are PQR respectively, where P is not equal to 0, show that P and Q satisfy. Okay, so let's see how we can do that. The first thing is try to understand the question. So plot this graph out. Of course, there are a lot of white space here which are wasted. I'm gonna just change this to like -4 and 4, just to stretch them out a bit. I'm gonna copy this graph in and try and understand. Show that the tangent at P, so this is P. I just draw a P here. Meets the curve again at Q. So let's say this is a tangent here. Meets the curve again at Q. So the first thing is you need to know this is your Q. Okay. Then the tangent at point Q meets the curve again in R. Okay, great. So this is R. You draw a tangent again. So this tangent here, I think is slightly, maybe just draw this tangent here. So maybe I should reduce my P because I want it to fit in the curve. Yeah, so maybe I that. Okay, good job. This is P. So this is P. This is Q. This is R. Like that. Okay. Then you're given the x coordinate of PQR are PQ and R directly. So this case here, this is P, this is P, comma. Of course, you want to reduce the amount of unknowns you have, right? This curve here is y equals to kx cubed. So if x is equals to P, the y value here, the coordinate here is kp cubed. Okay? So this is the first thing. So P is P kp cubed. Then you just do the same for the rest. It's actually this is actually Q kq cubed. And R is R PR cubed. First, I must understand this question here first. This is the one that you understand down. Then the next part is show that PQ satisfy QP plus PQ minus R equals to 0. Okay. So now what is the problem here? The problem here is essentially, look at this one carefully. This is PQ, this is PQ. Essentially you are just looking at P and Q lah, the direction here, P and Q. Just PQ right? So very quickly, we know that this is MPQ. MPQ here is dy dx when x equals to P or Q. MPQ here is P or Q. The gradient x equals to what? Which one? P or Q? Gradient at P. Gradient at P. Yes, is P. X equals to P. So sometimes students get confused. They don't know which one to put. It's P because it's the gradient at P. Then essentially you just find dy dx. So dy dx is equals to 3k x squared. So this is 3kp squared. Okay. Then what do I do? Because this is also y1 minus y2. y1 minus y2 equals to x1 minus x2, which is actually 3kp squared. So you just do kp cubed minus kq cubed over p minus q equals to 3kp squared. Then what you do is just slowly cancel this out. Okay. Then difference in cube, you can use the formula here, is given. You don't need to memorize. Usually if you need to use it, they will ask you to use it. They will give it to you. Okay, there you go. What you do is you cancel away. Make sure you understand when you cancel away. This one cancel here and here. Here and here. Since P cannot equal to Q. P cannot equal to Q, right? Understand why you can cancel this since P is not equal to Q. When you cancel away, you essentially cancel away one potential solution. So this potential solution is P equals to Q. So since P not equals to Q, that's pretty okay. Then you just write down this is P square Q square 3P square. This is Q square plus PQ minus 2P square equals 0. Okay. You want to manipulate to this case here, right? So you look at denominator is P square. So divide everything by P square. Look at denominator, guys. There's a reason why it's called denominator. That is the denomination that you're using, like the denominator, right? So divide by P. So this is okay. 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 Second part very fun. So part 2, show that PQ and PQ are three consecutive terms of a GP. So meaning you need to show P over Q is equals to Q over R. That's the first thing you must be able to tell. Okay. Now for the first part, we have the relationship between P and Q. Okay. So now you need the relationship between Q and R or P and R, doesn't matter. But in this case, you need to be able to show. Okay, how do you show? So this hear me out carefully. P is to Q is the same as Q is to P, right? Point P is to Q. Can you see that P to point Q would yield from the first part Q over P square plus Q over P minus 2 equals 0. So P to Q is Q over P square plus you get this, right? Right? When P is a tangent. Now, but if P is a tangent cut at Q, you get this equation here. So similarly, if Q is a tangent to R, so Q is to P, you similarly, okay, from 1, okay, just from 1, similarly, Q is to P would be, now you get the same result here. So Q is to P is to Q, so this will be, you see this P here, P is below here, right? P is below here. So if it's Q, then Q will be below here lah. Right, then, okay, sorry, Q is to R. Because if P is to Q here, then Q is to R here. Okay. So you repeat the same step as the first part, you will get the same. Q is to P, Q is to R. Okay. So this case here, what we get is R. Like that. Understand? Understand? Give a thumbs up. Comes the other part here. Now, why in the world they ask us to find this form here? I've done this in class before. Why do they ask us to find this form here? Because why Q over P square plus Q over P minus 2 equals 0? Why? You should know. Because this is a quadratic equation. You can solve it. You can solve Q over P. You have to remember that. Please write this down. This one we can solve. So from here, you know that hence let x equals to q over p. So x squared plus x minus 2 equals 0. So this will be x, what? X plus 2, x minus 1, is it? X squared, x minus 1, yeah. Correct, yeah. So x equals to minus 2 or 1. So q over p equals to minus 2 or 1. Okay, reject. This one will also give us r over q equals to minus 2 or 1. So since q over p equals to, because if you solve q over p and r over q, they'll have the same solution, alright? So equals to r over q. Hence PQR are consecutive terms of a GP. Consecutive terms of GP. This will be equals to 2 since a common ratio, because they already use r there, annoying, now equals to 1. So thus since QP equals common ratio is 2, GP is not. Okay, there you go. Okay.